The second major kind of relationship that you use in UML class model diagrams is generalization. Generalization is also indicated by a solid line, but in this case the line ends with a triangle. The class rectangle that's adjacent to the triangle is the superclass or parent class, and the other class rectangle is the child class or subclass. The semantic import of generalization is that all instances of the subclass are also instances of the parent class. That is, there's a subset relationship. Let me warn you, though, that generalization is not the same as inheritance in object-oriented programming languages. Inheritance is an implementation technique. Generalization is a modeling approach. We'll see how that difference plays out later in the course. In UML, generalization supports both multiple parent classes for a given class and multiple child classes for a given parent class. Moreover, you can specify discriminators, that is, names of groups of subclasses. So here's an example of a UML class model diagram in which generalization is illustrated. We have a superclass called vehicle. Note that it's got 4 lines coming into it, each with an open triangle, so it's got 4 subclasses. Those subclasses are wind-powered vehicle, motor-powered vehicle, land vehicle, and water vehicle. Notice also that we have 2 grandchild classes. We have trucks and we have sailboats. So let's think for a minute about trucks. Trucks are motor-powered vehicles, but they're also land vehicles. That is, truck has 2 parent classes. Similarly, sailboat is a wind-powered vehicle and a water vehicle, so it's got 2 parent classes as well. With respect to the parent level, we have 2 categories of subclasses. We have a category related to the power that moves the vehicle. It might be wind or it might be motor. And we have a category that's labeled here as venue, indicating where the vehicle does its moving. Is it on land or is it on water? Also visible in this diagram are some properties in curly braces. Those properties indicate properties of the subclasses. If a parent class has 2 child classes, and instances can belong to both of the child classes, we want to use the overlapping property. If that can't be the case, that is, if a given instance can only belong to one child, we say that those particular subclasses are disjoint. Their members belong to one of the child classes, not the other, but by our definition of generalization, the instances do belong to the parent class. A second kind of constraint or property we might want to express is whether or not the set of child classes covers all of the instances or not. If that's the case, we say we would use the property complete, and otherwise we would say incomplete. Why might a modeling situation be incomplete? Well, you might have some weird hybrid vehicle that doesn't belong to any of the child classes, but nevertheless we want to have an instance that recognizes it or models it, say the Segway, for example.